Alright guys, so you should have this paper out. Be ready to follow along. There's a few things we'll cover real quick that you should probably know, and then start talking about the stuff that you don't. So, just a reminder about triangles, okay? You have different types, right? We have an equilateral. We call it equilateral because all its sides are equal. Notice that we use little hash marks to talk about when sides are congruent. Okay, we also do angles as well. An equilateral has congruent angles as well. Okay, we also have the isosceles. Okay, where just two of the sides are congruent and two of the angles are congruent. Okay, now notice typically when we're looking between more than one triangle, which is what we're going to get to, you can use two marks to distinguish different sides and two angles to distinguish that these sides are not congruent to these, nor are the angles congruent. Okay. We also have right angles, which with the 90-degree side, right? Call the side opposite the right angle the hypotenuse. The other two the legs, which can or may not be congruent, depending on which type you have. So that's a right triangle. Okay. We also have, we can classify them by their angles. If their angles are less than 90 degrees, like these, we would call it an acute isosceles. If the angles are equal, equiangular, equilateral. Though we often don't use both of those. And then finally we have what we call the scalene, where none of the sides are congruent, so I can't draw any marks. And if we look at this one, we should notice that that's going to be an obtuse as well. That angle that's greater than 90 degrees. Okay. A few other things we should remember about triangles. In right triangles, we can use the Pythagorean theorem to solve for sides. A squared plus b squared equals c squared to connect the sides. The angles should always add up to 180 degrees, okay, in a triangle. We can also deal with area and that kind of stuff, but we're not going to talk about that. So let's talk about what we've been doing. We've been doing transformations. And the kind we've been dealing with are rigid transformations. Okay? There's non-rigid transformations, which we didn't really get into. And those would be like stretches or dilations. Dilations are when you have a smaller shape that you make a bigger shape. Okay? So it would all grow to that bigger shape. Or if I take one and then I stretch it out, a horizontal stretch, so I'd pull from here and here to stretch it out, or a vertical stretch where we would, pull here and stretch it out vertically. Okay, those would be non-rigid ones. Okay, but we're dealing mainly with rigid ones. Okay, so we can remember, regardless of whether we took a triangle. Okay, the types of transformations we did, let's call this ABC. Okay, so let's get rid of these guys. So, we also need to understand how to name triangles. So looking at this triangle, I would name it triangle ABC. Okay, I could also name it triangle BAC or triangle CAB, or any number of different versions. It really doesn't matter the order until we get further on. Okay? Remember, this is also considered our pre-image, right? Our pre-image here. So, we had those different types of transformations. So we had one was a reflection. Let's do a reflection. Reflection across this line, okay, of x equals 2. So I'd count the distance and then go that same distance. So right here, go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 would be that point. Okay. For this one, 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Right there at the end. Then C, 1, 2, 3, 4, 5, 6, 7. So we go out to 7, and it's right there. Okay, and we call that A prime, B prime, C prime, and that would be our image. Okay, and that was a reflection. Now remember, if we reflect across a vertical or y-axis, the y values stay the same because it's on the same line. The x values became opposite. If it was like the x-axis, a horizontal line, then the x values would stay the same, the y values would change. Okay? Now let's say we rotate it around the origin. So we could rotate it 180 degrees. So if I rotate it 180 degrees, each one of these points is going to flip and become the opposite. So this point of, so that's -6, +6, now becomes +6, -6. Okay, the positive and negatives change. And it would go down here. Okay, same with B. Okay, another way you can think about it is looking at B. B, we have to go up 1, 2, 3, 4, 5. To the left, 1, 2, 3. Okay, so if I take that same, and since we're rotating it around, if I rotate it at 90 degrees, we'd go 5 and then 3. So rotating 180 degrees, we take that whole side and move that same distance to get right here. Okay? So let me undo that so we don't have that clog in our space. So it's right here. Okay, so this would be B, we'll call it double prime, A double prime to distinguish it from our other transformation. And then C, same idea. It's 1, 2, 3, 4, 5, so -5, +3. So it switches to +5, -3. And we have another transformation, right? Okay, all the stuff we've been dealing with. Okay, now that was our rotation. We have our reflection, our rotation. We also have the translation, also known as a slide. So let's say we take our x and our y values, and we're going to, let's go left. So x goes left 3, and y goes down 8. Okay, could also have been written left 3, down 8. So each one of these points I move 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, right here. And 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay, we'll call this A triple prime, B triple prime, and C triple prime. Okay. Now, because these are rigid transformations, each one of these versions, okay, is going to be the same. Did we affect any of their distances? Okay, that length. We could use the distance formula. Remember, distance equals square root of x1 minus x2 squared plus y1 minus y2 squared, and solve that out. And we could prove that every single distance is going to give us the same thing. Okay? Now, I don't really want to take the time to do that because I don't think that's really relevant, but maybe at least for one of the sides we could hurry and do that just to show us. So that point was -3, 5. This point was -5, 3. Okay, the B point was here, 3, -5. and C was 5, negative 3. Then this one, 4, 5, 6, 7. So 7, 5. C would be 9, 3. Then over here, negative 1, 2, 3, 4, 5, 6, 7, 8, negative 8, negative 6, 1, 2, 3, negative 3, 1, 2, 3, 4, 5, negative 5. So if we found the distance of all those four, they should end up being the same. Okay, it's just one way, and we could do it for all three and see that they're going to still be the same. All right. So let's do this. So I do the distance formula, square root of. We'll start with A, B, C, D. I'll do that in here. So x1 minus x2 squared plus y1 minus y2 squared. Okay. So negative 3 minus a negative 5, that's like plus, so that would be a positive 2 squared, plus 5 minus 3 would be a positive 2 squared. 2 squared is 4, plus 4 would be 8, so we have the square root of 8, whatever that is. Okay? So let's see if we get the square root of 8 for all the rest. Okay, now let's do the reflection. So we'd have 7 minus 9 squared plus 5 minus 3 squared. 7 minus 9 is negative 2. Negative 2 squared is 4. 5 minus 2 is 2. 2 squared is 4. 4 plus 4 is 8. So once again, square root of 8. So those two definitely are the same. Let's take a look now at our rotation. So we have an x value of 5 minus 3 squared plus negative 3 minus negative 5 squared becomes positive. Positive 2 squared plus positive 2 squared. 4 plus 4, square root of 8. So this side is also square root of 8, as it was here, as it was here. Now we're going to check that last one. Okay, so we'd go negative 8 minus negative 6 squared plus negative 5 minus negative 3 squared. Negative 5 plus 3, negative 2 squared, positive 4. Plus negative 8 plus 6, negative 2 squared, positive 4. We get square root of 8 again. Okay? So what does that mean? That means, like I said, because of these rigid transformations, we're not changing the shape. So that means that all of our triangles, so triangle ABC, triangle A prime, B prime, C prime, triangle A double prime, B double prime, C double prime, and triangle A triple prime, B triple prime, and C triple prime are all congruent to each other. Okay, congruent meaning they have the same angle measure, they have the same side length. Okay. Now, just as we noticed, we tested these ones, right? These sides. So those are what we call corresponding sides. Okay. Corresponding sides are in the same position, as are the corresponding angles. Notice when I name BC, or prime, or double prime, or triple prime, it's in the same order. That's important when we deal with looking at congruent triangles. Okay, just like AC should be congruent to A prime, C prime, A double C, and AC. It can't be congruent to this other one because we didn't make it that way. Okay, so those would be those pieces. Notice they're once again in that same position. Okay, as are AB, the ABs of all of these, right? Okay, the ABs are also. Okay, it also means that our angles are going to be congruent. So angle A's would be congruent because they're all the corresponding pieces. Angle B's would be congruent. Okay, as well as angle C's. Kind of run out of room. So today, that's kind of what we're going to practice, is understanding the different parts, how they connect, and what they tell us about these triangles. Okay. So I'm going to do a couple of examples from each section, so you know what to do. Then you'll have time to work on it on your own, and we'll go from there. Also, when we're writing congruency between two things, we use an equal sign with a toupee on top. That means they're congruent. So let's take a look and see what we've got. So this first section here, 12 through 7, okay, wants us to complete each congruency statement. Okay, first thing to notice is the order of the triangles. See how K is first and Y is first. If I look at angle K and Y, see how they have 1 mark? That means they're congruent. Same with L, 2 marks. X, 2 marks. They're both in the middle. M, 3 marks. W, 3 marks. Okay, if we talked about in terms of sides, side KL, 1 mark would be with YX, 1 mark. LM, 2 marks, with XW, 2 marks. And the 3 marks, K and M and Y and W. Okay, that's important to understand, that order matters in the triangle when you're dealing with more than one triangle. So what do we want to do? We're just going to say, okay, LM is congruent to what piece? So LM is a side, has a line above it telling you it's a side. It's got the 2 tick marks. We know these 2 triangles are congruent, so we look for the 2. Okay, so it's XY. So you write, not XY, XW. Or you could write WX, same thing. Okay, and that's all you're doing on these first ones. Okay, so same with number 8, look for the sides. Okay, number 9 wants you to find an angle. Now, there's a few different ways you can write the angle. This angle right here, when you have 3 letters, the Y is the vertex, so it would be W to Y to X. So it would be that angle right there. The corresponding angle, you can't just call it angle W, because angle W could be this angle right here. It could be this angle right here, or it could be both those angles combined and be that large angle. So that's why we have to use 3 letters. So we notice that the one we had 2. So we look for the 2 tick marks. So it would be FWY. So I'd go angle FWY. Or YWF, that would work as well. Okay? Alright, so you should be able to do the rest of those. Okay? Now, 13 through 18 here, okay, they want you to mark which ones are congruent. Okay? Based simply off the name. So the easy thing to do is to look at your letters. So I've got B first, so that tells me this angle and this angle are going to be congruent. Then D and J are next, so angle D with angle J, and so I put 2 tick marks. Then C and K, which would give me 3. Okay? Once you've got the angles, it's pretty easy to figure out. You just look at sides that correspond. So as we look at this, we match it up. So 3 to 1 would be 3 to 1. So that tells me that side CB corresponds with BK. Or we look at the order again. B first, C last, so B and K have to work. Okay? Then we look, going back the other way, okay, I've got J to B would be D and B. Okay? Notice the 2 letters together. So we call that the second one. Notice I put a different number of tick marks in there. Okay, which means CD, the last one, or DC, same thing, has to be the same with JK, or KJ. So that's all it wants you to do, is to mark those up according to what is the congruency statement based off of that. Okay? So you should be good for those ones. Okay, taking a look at 19 through 24, now we're going the opposite way. Now they told us, they are showing us what's congruent. We have to write the congruency statement. So let's start with the first angle. We'll do 20 on this example. So angle I, so triangle I. Okay, then let's go 2, which would be G, then 3 would be that H. On that side is congruent to, equal sign with the toupee. Okay, E would correspond with I, so we do E first. Oh, forgot my little triangle mark. Triangle E, and then 2, so D and G correspond, so D, and then back to H again. So it would look something like that. Okay, so you've got to make sure that order matches the angles and would also match the sides. And that's all you do for those ones. Okay, so that'll get you to 24. Alright, now these last ones, okay, you are completing the congruency statement without any other tick marks. Okay, so if we look at 26, so ML. So ML would be right here. ML would correspond to G and H. So it would be right there. So side GH. Okay, and then finally, these ones don't even give you a picture, so you're just basing it strictly off looking at the order of the triangle name. So we could do an angle, so like 30, angle S. S is in the front, so it would be angle M. When you name an angle, it has a little angle in front of it. Okay, if you did an angle like this, or this one, you simply follow along with their order. So this goes Z, then X, then Y. So I have to go U first, then X, then T. So it would be angle UXT. Okay? So I think you can handle the rest of the angles for sides. We just try to match them up. FH is the second and the last, so it's going to be PR. Okay? So you guys need to finish the rest of this. Honestly, I think you probably will be fine finishing it before the end of class. I would try to get it done and hand it in. It is due tomorrow when we come back. And if you can all get it done, and if you have a little bit of time, I'll do a video where we answer all the rest of the questions. And you can get some help or check your work on the other ones.